Okay, welcome to JC Connect. In the previous class, we were discussing about the importance of the lab and where it is used and how we have to use this lab as a social importance. That all we have discussed, and also we have discussed that around 11 experiments are there for conduction, 3 experiments for the demo experiments. So we also learned the course objectives and we also learned the course outcomes. So, and um, I recommended uh, some of the textbooks. They are very good for as a future point of view as well as the examination point of view. And I have also explained about the examination pattern. The 2 experiments will be given. The first experiment is for conduction, and the second experiment is for the write-up. Uh, so we move on to the first experiment, that is the preparation of the chemicals required for analysis and sampling methodologies. Today we'll try to cover some of the very basic terminologies normally we'll use in our laboratory process and some of the very important chemicals and their formulas. Maybe some of you are from a PUC background and some of you are from the diploma background. For the diploma background, maybe you learned some of the, you have not learned some of the terminologies um, related to our environmental lab. Um, so when we start about that, the preparation of the chemicals, normally we'll use some of the terminologies. We'll always will use that. So should know all these terminologies uh, till completion of your lab. First one, that is we already discussed that is BOD. You already know that because you already completed 18CV55 course. Then we'll use some of the, this we don't know, that is bleaching powder, BP, that will use it. Then BR stands for burette reading. So burette is the one um, um, glassware. It is a glassware. Burette is a glassware used to make the titrations. So normally it is used for, burette is used for the titrations. So it will be up like this normally. So here the graduations will be there. Graduations will be there. So will be big. Um, in this graduations, it has, this is a burette stand. Burette stand. Then we have the COD, that is a chemical oxygen demand. We'll use the abbreviation as a COD. Then DO, that is always we'll use it as a dissolved oxygen. Then DW stands for the distilled water. DWD stands for the distilled water. Then DS stands for double strength. This double strength means, for example, I'll explain in terms of the normality and molarity in the next page. Maybe in that time I'll explain what is double strength, what is single strength, like that. Then EDTA, it is normally used for the um, titration. There's a titrant is used in hardness experiment. This is also one chemical. Then FAS, this is also one chemical, that is ferrous ammonium sulfate. That we are using it in the preparation of the standard solutions in iron experiment. Iron experiment, you'll use this, that is ferrous ammonium sulfate. FAS stands for ferrous ammonium sulfate. Then LPG you already know. Then MBAS, it is methylene blue active substances. Rarely we'll use this terminologies. Then again, this is some of the terminology like microsiemens. Thus, there is the unit of conductivity. Normally, the unit of conductivity in our experiment is microsiemens per centimeter. We'll use this as microsiemens. Okay. Always you have to use the units in a standard format only. Don't write like uh, micro Siemens. It is wrong. Then you have to use the this terminology only. Then micrograms will use the terminology called this is micrograms. Then you have to use the ml. Many people will use that milliliters, LITRE. So you're not supposed to use like that. You have to use this abbreviations only. Then millisiemens, that is M. This is used in our conductivity again. Then milligrams, you have to use. You're not supposed to use like this. Again, milligrams, wrong. It is wrong. So then milligram per liter. This is used to find out the strength of the solution. Strength of the solution. Then nanometers. After that, we'll use the M. That's capital M stands for the molarity. That I'll explain what exactly this molarity is and what exactly this normality is. So then MPN, that capital M, capital P, capital N stands for most probable number. It is used in uh, to find out the bacterial count in an water sample. Then the NM stands for nanometers. This you already know. Then NTU. NTU stands for nephelometric turbidimetric unit. Nephelometric turbidity unit. Then N stands for the normality. That I'll explain what exactly is normality, molarity. Because our first experiments itself is the preparation of the chemicals. We should know all these terminologies. Then uh, NBP, that is stands for normality of bleaching powder. So N then subscript BP. Normally you'll use it. Then ppm, that is ppm is nothing but parts per million. Parts per million stands for the, it is the same as ppm, that is equal to, ppm stands for milligram per liter. Both are same. Then PAH stands for polynuclear aromatic hydrocarbons. Rarely will use this terminology. Then QTI, that is short form of quantity. Then RPM, you already know, revolutions per minute. Then S, that is capital S, always stands for, it is Siemens. Then SS stands for single strength. DS stands for double strength. Then TDS stands for the total dissolved solids. I'll explain that in the solids experiment. What is that? Uh, TDS. Then UVVIS, that is ultraviolet visible. UV stands for ultraviolet. Then VIS stands for, it is visible. Then VBP will use it for our volume of the bleaching powder. Volume of the bleaching powder. Then WT, capital W, small t, that is weight. Normally we use it as a weight. So then these are some of the common terminologies. Normally we'll use it in our environmental engineering laboratory. And you should know these are the minimum terminologies. Still many are there, but I have not included all those things. Frequently what terminologies we'll use it, that only I have included. So next, move on to some of the chemicals and chemical formulas. We'll use it in our lab. First one, there is a silver nitrate. It is designated as the AgNO3. Okay. So capital A, small g, capital N, small O. That is a silver nitrate. So it is used in a chloride experiment. Chloride experiments. So then potassium chromate. So this is also used in our COD experiment. Then sodium chloride, we'll use it in chloride experiment. Okay, then chloride, it is designated as Cl. Then sulfuric acid, normal we'll use it. It is designated by the H2SO4. Then sodium hydroxide, it is designated by NaOH. You have to write in that way only. N is capital, A is small, O is oxygen, H is hydrogen. And no, you are not supposed to write O as a small and H as a small. So in the same format you have to use it. Then calcium sulfate, CaSO4. Then the magnesium sulfate, MgSO4. Then HCl, that is hydrochloric acid. Then normal will use the acids as three acids, that is H2SO4, then HCl, then HNO3. These three acids commonly will use in our laboratory. That is H2SO4, that is hydrochloric acid, sulfuric acid, then HCl, that is hydrochloric acid, then HNO3, that is nitric acid. Then sodium sulfate, that is Na2SO4, then carbon dioxide, then sodium thiosulfate, normally we'll use it in as a titrant for many of our experiment. Titrant. It is a titrant. So then calcium carbonate, then manganese sulfate, manganese oxide, so then water, that is MnO2 is a manganese oxide, water is H2O, that you already know. Then uh, magnesium hydroxide, that is MnOH twice. Then calcium chloride, that is CaCl2. Then FeCl3, that is a ferric chloride. Then K2Cr2O7, that is potassium dichromate. Lot of difference is there. Potassium chromate normally will confuse with these two chemicals. This one and this one. Both are different. Most of the time, instead of this, you will write in place of K2Cr2O7, you will write K2Cr2, K2Cr O4. Then silver sulfate, that is Ag2SO4. Again, you will confuse the silver nitrate and silver uh, sulfate. So then ferrous ammonium sulfate, that we already discussed, that abbreviations we have used previously, that is FAS, that is FAS. That is FAS. Then CS3COOH, that is acetic acid. This is acetic acid. Then again, some more chemicals they are there. That is Ki. This is used as an indicator, that is in a DO experiment. That is potassium iodide. Then hydroxylamine, NH2OH, HCl. Then ammonium acetate, that is NH4C2H3O2. Of course, and other things are there not that much important, but you should know some of the sodium, it is given by Na, potassium, then HNO3, that is nitric acid, then nitrate. So maybe you'll confuse with again when it comes to nitrate. So nitrate is NO3, then NO2 is your nitrate. Nitrate is totally different from nitrate. There always a difference should be there whenever we are explaining. Okay, then we'll start with the first experiment, that is preparation of the chemicals. So if I say the preparation of the chemicals, we'll use the different terminologies to prepare the strength of the solution. When I say it is strength, yes, strength is equivalent to the concentration. I'll use these terminologies: strength of the solution or the concentration of the solution. Sometimes I'll use the strength, and sometimes I'll use the um, I'll use the concentration. So uh, sometimes I'll tell you to prepare one normal solution, or one normality of the solution. So what this normality stands for, then how I have to prepare it, that I should know. If I'm saying normality means it is the strength of the solution. So that is, the normality is defined as the number of gram equivalent weight of substance dissolved in 1 liter of distilled water is called the normality of the solution. Then what is this gram equivalent weight is? What is this gram equivalent weight? Then how I have to prepare it? For example, uh, the gram equivalent weight of HCl, that is 36.5 grams. So what is this? How I have calculated this gram equivalent weight? What is this equivalent weight is? So normally for equivalent weight, we have some formula is there to calculate it. Equivalent weight, we have to calculate it in. I'll tell you how to calculate it. For example, equivalent weight, how we have to calculate it. Before that, we have one more called molecular weight. How the molecular weight is calculated? Before going to in detail about the molecular weight and equivalent weight, we have an atom. In an atom, we have proton, you have neutron, you have electron. So of course we will not go in depth, but if I want to calculate the atomic weight, before going to that, one more terminology called atomic weight, and one more atomic number. So in atom you have proton, neutron, and electrons will be there. Of course we'll keep this as inside, we'll discuss later. But atom consists of 3 elements, that is proton, neutron, and electron. Then what is this atomic weight is, or atomic number? For example, you take the sodium as Na, it is designated by Na. It is an element, and it is also an atom. Okay, then what is its atomic weight? That is, atomic weight is equal to 23. Normally if you see your periodic table there, normally it will be written like this: sodium, it is given by 23 like this. Then here at the denominator one more number will be there, that x. Here whatever they will write, that is atomic number, and this is atomic weight. This atomic number, it is nothing but a proton. It is nothing but a proton, that is atomic number, and whatever it will be there, it is atomic weight. Then molecule is nothing but a combination of 1 or 2 elements or 1 or 2 atoms. So for example, you have one chemical is there, NaOH. It is a molecule. It is nothing but it is an molecule. I cannot say it is an atom or the element, because it is combined with 1, 2, 3 elements. So Na plus oxygen plus H. Then how I have to calculate the molecular weight of, this is nothing but a molecule. How I have to calculate the molecular weight? So then atomic weight of all these elements, if you add it, you will get the molecular weight, that is 23 is an atomic weight of sodium, oxygen it is 16, then hydrogen it is 1. So then I'll get total 40 grams. Suppose if I take 40 grams, if I take 40 grams of NaOH and dissolve it in 1 liter, that I will get 1 molar of solution. 1 molar of solution. Say that is the molarity and normality. So molarity stands for, molarity is gram molecular weight. Gram molecular weight. Normality is gram equivalent weight. Next I'll come to what is that equivalent weight is first. First we discussed that we'll discuss molarity. Molarity is also used to find out the strength of the solution. Then at today's class you understand only the molarity, how the molarity is calculated. In the next class we'll discuss about the normality, because you should know the concept of equivalent weight, how the equivalent weight is calculated. So it requires again the basicity and acidity. We'll discuss that in the next class. Whenever you are calculating the molarity, 1 molar solution, 1 molar of NaOH, if I tell you to prepare, then first calculate the molecular weight of NaOH. Then always it will be that much grams, gram molecular weight. That much gram if you weigh it in a weighing balance, and if you dissolve it in 1 liter of distilled water, then you will get the 1 molar of solution. Suppose if I want to prepare 2 molar of NaOH, then I have to add 80 grams in 1 liter, not in 2 liters. Very important. It is 80 grams in 1 liters. I have to add, that you will get 2 molars. If I want to prepare 3 molar, then I have to go with 120 grams in 1 liter. So that I will get it in 1 molar of solutions. Similarly, if I dissolve it, that is 120 gram in 3 liters, then I'll get the same, that is 1 molar of NaOH only. So this is how we will calculate the molarity. Molarity is always the gram molecular weight of that substance that is dissolved in distilled water. So this is the concept related. Of course, we are not going in detail, but you should know how to calculate it. So 1 or 2 calculations will be given in your examinations to calculate or to prepare the strength of the solution. So the remaining we will discuss in the next class, that is equivalent weight concept as well as the normality concept.